What if your data wasn't just this static snapshot, but a living, breathing history book that you could read from cover to cover? That's the core idea behind a really fascinating technology we're going to dive into today, Xorcery Aurora.
I mean, think about it for a second. Most systems, they're great at telling you what your data looks like right now. But what if you need to know what a user's profile actually looked like 3 months ago? Or track every single little change that led to its current state? Yeah, that's a much harder problem to solve.
And that is the exact problem Xorcery Aurora was built to solve. It's an event-driven platform that uses a graph database to build out that complete history. It's all about capturing not just the what, but also the how and the when.
All right, so here's our game plan. We'll start with its event-driven architecture. Then we'll see how it actually builds that graph timeline. After that, we'll dive into how you can query through time. And finally, we'll show you exactly how you can get started with it yourself.
So how does this whole thing actually work under the hood? Well, it all starts with the foundation, a super powerful event-driven architecture that turns a simple stream of data changes into this rich web of insights. Okay, let's look at the core pillars that make this tick. First off, it's event-driven, which just means it reacts to changes as they happen. It's also built for multi-tenancy, so you can be sure that different clients' data is always kept separate and secure. Now, this next one is absolutely crucial. It handles temporal data. Every single change gets a valid from timestamp. All of this history is stored in a graph data model using Neo4j, which is just perfect for understanding complex relationships. And the best part? You get to access all of it through a really flexible GraphQL interface.
Okay, so let's trace the journey of a single piece of data here. It all starts up top with client apps talking to a really clean GraphQL API. From there, the request gets fanned out to different modules. You see things like search or AI, but for our purposes today, the key destination is that Neo4j Graph Projections module. That's the engine room, right? That's where the magic of translating raw events into the graph happens.
So how does Aurora actually build this incredible historical timeline from just a simple stream of events? Well, the magic, the real secret sauce here, is a process called event projection. This is what's responsible for turning those events into a rich, interconnected graph.
And the flow itself is actually super simple and elegant. First, raw events just stream into the system. Think of things like user updated their email or order status changed. Next, the event projection logic kicks in and translates each of those events into a graph update. And finally, that update gets committed to the Neo4j database, building out that historical record piece by piece.
So what does this graph actually look like when you peel back the layers? It's really built from just a few key types of nodes. You've got your tenant node, which keeps everyone's data separate. Then you have the entity, which is your core object, like a user or an order. Every time that entity changes, a changes node is created to record exactly what happened. And based on that, a brand new snapshot node is generated to represent the state of that entity at that exact moment in time. It's a beautiful system.
All right, so we built this amazing historical graph. Awesome. But how do we actually use it? This is where the whole thing really comes alive, allowing you to ask incredibly detailed questions about your data's past. This is where you, the developer, get to play. You interact with all this amazing data through GraphQL, and Aurora hands you this really powerful toolkit to get the job done. It gives you specialized schemas like changes.gql to track attribute history and timeseries.gql for time-based analysis. This makes your queries not just powerful, but also predictable and honestly pretty easy to write.
And check this out. Here's what a query might actually look like. It's so clean and readable, right? We're just asking for all the changes to the entity user 123 that have happened the last 30 days or 30 days. And for each change, we want to know when it was valid from and which attributes were modified. It's such an intuitive way to ask a very complex temporal question.
Now, of course, for any system like this, especially in an enterprise setting, security is absolutely non-negotiable, and Aurora tackles this on a couple of key levels. First, data is strictly isolated by tenant, so you only ever see your own data, period. On top of that, it supports attribute-based access, which means sensitive fields can be automatically hidden or reducted based on who's asking.
Okay, this all sounds pretty powerful, right? But the best part is, it's not some far-off theoretical thing. You can actually get your hands on it super easily. Let's just walk through what it takes to get a local instance up and running.
Seriously, it boils down to just 3 simple commands in your terminal. You clone the repository from GitHub, you build the project using Maven, and then you just run the tests. Once that's up and running, you can immediately start projecting your own sample events and exploring the graph you're creating right through the GraphQL interface. It's that easy.
And that really brings us back to the most crucial point, the fundamental shift in thinking that Aurora represents. It's not just about storing data, it's about storing its entire history as a graph that you can explore.
So that leaves me with one final question for you to chew on. If you could ask any question about the history of your own data, what would you ask? What secrets, what trends, what insights are just sitting there hidden right now, waiting to be uncovered? Thanks for tuning in.